Synchronizing relays are of great importance when it comes to ensuring a safe connection in a variety of switching operations. The principle behind these devices is simple. Synchronizing relays are able to measure two voltages with respect to phase angle, frequency, and magnitude in order to safeguard against the interconnection of two unsynchronized systems. For testing this type of relay, TestUniverse includes the Synchronizer module. In this video tutorial, we will test the active synchronization functionality when connecting a generator to the network. During the so-called active synchronization process, the relay uses control commands to adapt the amplitude and frequency of the generator voltage to the conditions of the network. At any moment, the synchronizing device is able to check whether the conditions for switching on the circuit breaker are being met. Once this is achieved, the relay issues a circuit breaker close command. If the conditions are not met within the maximum synchronization time, the process is aborted. The allowable amplitude, frequency, and angle deviations between the power system and the generator voltages are defined in the relay under test. The relay that will be tested in this example is the Siemens 7VE63. Since we are about to test a new relay type, we will open a new OCC file. This document will contain the Synchronizer test module. According to OMICRON's Ohm's law, we first configure the global test object. As usual, the device block will contain the general device settings such as the name, manufacturer, and nominal secondary values for the reference system. As you can see, a new REO block is available to define the parameters of the synchronizing relay. The first tab contains some information about the systems that need to be synchronized. System 1 is always considered the reference system. Its values for secondary and primary nominal voltages are set in the device block. If the secondary voltage of System 2 differs from System 1, clear the Use Ratio of System 1 checkbox and input the corresponding value in the edit box underneath. Select the direction of the phase rotation and choose the voltages that need to be compared in the Connected Voltages drop-down menu. The CB closing time box shows the time that has been set in the CB configuration REO block. This is the time between the output of the CB close command and the actual closing of the circuit breaker. The CB closing time is used to calculate the phase angle difference between the two systems at the time of the CB closure. The transformer group field allows you to specify any phase shift from a coupling transformer. The Start-Release drop-down menu specifies the type of signal that will be applied to the test object during the synchronization process. This option has to be set in accordance with the logic of the relay under test. You can choose from pulse, continuous, or none. The pulse option uses the start and release signals for attempting and aborting synchronization. The continuous option ensures that the start signal is output during the entire synchronization period, but no release signal is issued. The none option does not issue a signal during the process. In our example, we will compare the phase-to-phase voltages of both systems. We keep the same VT ratio for systems 1 and 2. The relay requires the use of start and release signals, so we will use the pulse option. The Synchronizing Window tab contains more details about the synchronizing characteristic of the relay. Since the magnitude, frequency, and phase of the voltages have to match in both systems, we need to specify the allowable range together with the tolerances in absolute and relative values. Some relays check that the synchronization conditions are met for a certain time. The minimum synchronizing time edit box is available for this purpose. Dead zones are areas where the relay will not output any control commands. The existence and size of the dead zones depends on the relay's configuration and its parameterization. When defined in the test object, they will be displayed in the test module. However, these zones are not assessed during the test. In other words, they serve as an aid for visualizing the relay's behavior, but have no actual influence on the test. The Siemens 7VE63 has not been configured to have dead zones. For this reason, we will set them to 0. The relay settings are shown in the screen so we can enter the values. With regards to the hardware configuration, we choose a general configuration with 4 voltage outputs and no currents. For this test, we need 2 output voltages. One of them represents the phase-to-phase voltage of the network, while the other is the phase-to-phase voltage of the generator. Regarding the binary inputs, 4 of them will monitor the control command signals of the relay. That is, 2 signals can raise and lower the voltage magnitude, and 2 more signals can raise and lower the frequency. An additional binary input will be used to monitor the relay's circuit breaker close command. Finally, 2 binary outputs will be used as control signals for starting and aborting the synchronization. Now, we are ready to configure the test module. Check out the next video tutorial to learn how to configure the Synchronizer test module.